Have you ever wondered how the casino always seems to win? Or do you know what your actual chances are in a game? A lot of it comes down to this one core idea: independent probability. So let's jump right in with a puzzle. Imagine you bet a friend that you could flip a coin and get heads. Not just once, but twice in a row. Your gut might be telling you that the odds are still 50-50, but is this actually true? Let's find out the exact answer. Before we get into it though, we've got to make sure we're all understanding the key terminology. The language of chance. So here's our first terms. Probability itself. The easiest way to think about this is just a score on how likely something is to happen. It's going to be on a scale from 0 to 1. 0 means totally impossible. You know the chance of like rolling a 7 on a dice? 1 is absolutely certain, like the sun rising tomorrow. Most things in life happen somewhere in between. An independent event basically means it has no memory of the thing that happened before. A coin is a classic example. If you flip a coin and get heads 5 times in a row, the next flip doesn't change at all. It's a simple idea, but it trips up a lot of people. So an independent event is like rolling a dice. Getting a 6 has zero effect on what you do next. A dependent event, however, is like drawing a card from a deck. If you pull out the ace of spades and keep it, the next person's chance of getting the ace of spades has gone all the way down to 0. The second event was directly affected by the last one. That's the difference. Right, that's the key vocab. Let's get to the tools that do the work. It's the multiplication rule, and it's how we're going to calculate the odds of a whole bunch of independent things happening one after the other. Here's what you do. You just multiply the two probabilities together. That's the entire rule. It's that straightforward. You can think of it as 3 separate steps. You just got to find the probability of the first thing happening, then the probability of the second thing happening, and then you just have to multiply those two numbers together. That's it. So let's try it out with a little puzzle. We were talking about flipping a coin twice and getting 2 heads in a row. That means we need heads on the first flip, heads on the second flip. And if we use our rule, we can figure out the answer. Step 1. Probability of getting a heads on the first flip is 1/2, or 50%, or 0.5. Step 2, the same thing. We're doing the same thing. The second flip is also 1/2. Final step, we just have to multiply them. A half times a half gives us 1/4. So the probability of getting 2 heads in a row is actually 25%. Let's look at it visually. You can see it drops all the way down from 50% for 1 heads down to 25% for 2. And if you keep adding that, if you keep adding on a third event and a fourth event, it will keep getting less and less likely. Let's try one more example. We'll leave the coin behind. Now we're going to look at a standard 6-sided die. What's the odds of rolling a 6 and then another 6 straight after it? It's the same logic. It's the same rule. The chance of rolling a 6 is 1 in 6. The chance of doing it a second time is still 1 in 6 because it's independent. So then we just have to multiply them and get 1 out of 36. So that's the reason that these things can become very difficult at a casino. And this is the key thing behind the gambler's fallacy. But it's not just in gambling. It's in video games. It's in finance. It's even in medicine. Probability is really the thing that kind of guides everything in life. Once we can understand probability, we can kind of see the world through a whole different lens. It helps you separate random luck from something you can actually predict. And you can explain something as unlikely as a 1 in a million chance, but it is just math. You can make something that seems unlikely make sense.